right. Wow. Packed room. This is a cool room, actually. Kind of like it. It reminds me of lectures back in college, which actually might be a little bit traumatic, so never mind. But thank you for attending today. I am Nicole Archambault. You guys can hear me okay, right? All the way in the back? Cool. I am Nicole Archambault, and this is my second ever conference talk. I'm excited. Abstractions seems like a really cool place to do a talk, and hopefully you're enjoying your conference so far. And yeah, so we're going to be talking about two topics today, and y'all might be here for one or the other, or if you're super nerdy, it might be both. But we're going to be talking about multi-user dungeons, text-based role-playing games, and object-oriented JavaScript. So yeah, let me start out by telling y'all who I am. And if you don't know who I am already, I kind of have a weird Twitter presence. So like I said, I'm Nicole Archambault. And here's what I do in a nutshell. All right, I teach fundamental skills, the skills that are usually overlooked by a lot of the other learn to code institutions. And they're virtually non-existent, even in self-teaching. And I am a self-taught web developer as well. But those skills, that I'm teaching are problem-solving skills and autodidactism, so the ability to teach yourself, which is really critical for any of us because no matter where we learn, we're going to need to continue learning independently at some point. Everything changes way too fast. But yeah, I used a lot of those online e-learning platforms to teach myself to code, build those skills. And then I was able to at least convince somebody that they should hire me. So I winged it from there. Winged. I winged it from there then. But and another thing that I talk about often is that I'm actually a computer science major dropout. I was trying a computer science degree at Wellesley in college, or Wellesley, but it just got to be too much for me at data structures and algorithms. So that's a really interesting part of my story that has led me to connect with a lot of different people because maybe it's a point of shame or something like that. I don't know. I've given up on the shame. But it was so effective for me to learn online versus in an actual classroom environment that I was pretty much floored because I became addicted to learning. And I wanted to figure out why it was that it worked so heckin' well. So I ended up getting into the educational technology sphere, where I work all the time with using technology to help people learn. People in the programming community, self-taught coders, even computer science majors. Like I said, a lot of that stuff that I work with, those fundamental skills, turns out aren't so fundamental in terms of being able, Has anybody here actually had formal training in problem solving? Or did you just kind of figure it out? Oh my God, really? Wow, okay, yeah. I mean, it's one of those things you hit your head against the wall enough times and you'll probably seek help. But yeah, I started creating online courses for other coders as well as course and coaching programs. I have a flagship program that is a career changer school for people like myself, and another one coming up in September called Newbie Coder Problem Solving School. So that's where I'll really be taking these new coders and hopefully taking them to the next level. And both are code agnostic and 101 level. That's the stuff that I deal with. But I kind of think of them as like a jetpack for e-learning. And yeah, so that's what I do. So part two, what are you going to learn today while you're sitting here in this lovely auditorium? Really, I'm going to start out by talking about what text-based role-playing games and MUDs even are, because, like I said, some of you might be here for object-oriented JavaScript. You might just be curious, but MUDs are actually really fun. And this is a very newbie coder-friendly talk for that reason. There is code in it, but and then finally, I'll connect them first, the MUDs and object-oriented programming. And then I'm going to model an actual in-game object. I would love to do more than that, but we can demonstrate some of the characteristics and the really unique characteristics and some of the cool features of object-oriented JavaScript. Okay, guys ready? Woo! Give us some energy, please. It's like after lunch. Woo! All right. Okay, so let's dive in here. So why am I here talking to you about object-oriented JavaScript and MUDs today? Like, I don't know, I'll explain in a second, but it's like, what is that, a MUD? Well, with a 20-year-old character and probably about 5,000 hours logged on her, You can see I spent most of my childhood and college time spending a lot of time in these MUDs and really getting myself immersed in this fantasy world that was offered. I'm a very creative person, so it really spoke to me. I really enjoyed it. So I love to spend hours dissociating my character, and I love object-oriented programming as well. I love JavaScript, but I love the way that object-oriented programming is set up. And I really started to recognize those connections between the two as soon as I started learning about object-oriented JavaScript, because, as we'll talk about, it turns out that everything in these games is an object. So we'll actually model those shortly, but yeah, there are a lot of also, I just think it's a beautiful way to encapsulate code. And we'll be talking about encapsulation as well and what that entails. But I also love examples and analogies. I think we all do. It makes things so much easier to understand. Oh yeah, this is my my old-ass character that I made when I was like 14, I think. And you can see it was like 2000, oh my God, 1999. Yeah. So you can see some of the things that make up a player's different attributes here. You know, you can see the reputation that you have. You can see the number of kills, number of deaths. I died a lot, role-playing stuff, which continent I was from. And this is all what makes your player unique. But at the end of the day, aren't they all kind of properties? You know, and we're just outputting them in different ways. So I'll show you how that works. It's just that a lot of these methods have been abstracted so hard under the hood that you can type something simple and user-friendly, and something happens under the hood. So we're taking a look today at what's under the hood. Oh, that's the wrong slide. Oh, no, it's not. I just hid them. Okay, so what are multi-user dungeons, and how are they different from text-based role-playing games? Well, text-based role-playing games are text-based computer games with many of the same mechanics as tabletop games that we know, like Dungeons and Dragons, for example. So we have things like dice rolls. We have things like player stats. We have player versus player combat, player versus environment combat. And the text-based role-playing games really abstract those randomized elements, so we don't have to have that 20-sided die in front of us and the 6 that's going to fly off the table and then it disrupts the whole game. So it abstracts all of those, the different elements, so you don't always see what's under the hood here. And that can be a good thing. But text-based role-playing games, here we go. So use those, okay. Text-based role-playing games can be offline also as an application. Has anybody here played Zork? Or anything? How did more hands go up for that than formal problem-solving technique? Deadass, like what is that? Okay. Yeah, wow, okay, lots of nerds here. So that was actually originated back in like, what, 1979, I think, or something like that. So we're talking really old school stuff here. But MUDs stands for multi-user dungeon, are actually a type of text-based role-playing game that's hosted on a server so that multiple people, or many people in this case, could play at the same time. And that MUD server software allows people to log in either via Telnet or you could download a client. There's lots of client options. And it accepts commands within the MUD world to make it happen. So that server software understands the commands that we enter. Oops, there we go. So players can interact with other players. You can interact with non-player characters, which are just randomly generated mobile characters, as we call them. And you can interact with objects in the game as well. And players can also move in between rooms. So you can see here that this is your typical room description. You know, it gives you the title of the room, it gives you the description of the room. You never want to make it that long, or else people won't read it. And it gives you a list of exits. So at that point, you could type something like north, south, east, and west, and it would load a different room for you. So it kind of gives you a very creative feel. You have to imagine all this based off the descriptions. That was very appealing to me. I love that stuff. Wow, okay, I didn't switch that out. But I think because I couldn't find anybody to role play with me, that's right. And I was super surprised, too. I was like, somebody role play with me, I just want to do it. But yeah, sometimes there actually is role playing in these games, and I don't really like it. I guess I did when I was younger, but, you know, I'm like, leave me alone, let me quest and kill stuff, and I'm good. But that's MUDs in a nutshell. It gives you a sense of what we're working with here, and then we'll slide into how it connects with the object-oriented JavaScript. So, MUDs originated in 1975 when programmer William Crowther, had created Colossal Cave Adventure. And it's really funny because he created this game with the specific purpose of just keeping his kids occupied. Like, maybe if you guys are parents, you can identify with that. Let's build something so that my kids won't bug me. And the first MUDs were predominantly coded in Fortran. Since then, I mean, today I found an open source repo for a JavaScript-based MUD client, and I'm like, I could work on that. But some of the early server software, it could only host between maybe 25 and 50 players at once. And that seems like a lot, but then when you consider other games, which we'll segue into, these were the predecessors to massively multiplayer online role-playing games, MMOs as we know them. But now they can support, the server software can host to get along many servers, and it can support hundreds of thousands in a region even. It's crazy. So we have lots of capability here with MUDs, and they're still popular today. So, yep, as I said, they're the predecessor of the massively multiplayer online role-playing games that we know, like Ultima Online, EverQuest, and my personal favorite, World of Warcraft, which I played for years and got really addicted to and was like first on the server for everything because I'm a perfectionist. But that's how we work. That's what keeps these people really engaged in these games. Keeps us spending money, keeps us spending time. It's big gaming. I can't call them. It's a conspiracy of big gaming. But yeah, the text-based versions are still alive, well, and quite popular. So, quick look here. What is object-oriented JavaScript? Well, object-oriented JavaScript is just object-oriented programming using JavaScript. Kind of makes sense. But what it does, it encapsulates our code in such a way that it's really based on defining and communicating the state of the object as opposed to in functional programming where it's more the function that's attached to the data that we're using and the structures that we're using, rather. So JavaScript is actually a particularly good fit for object-oriented programming, particularly because we've made a lot of quality of life improvements on object-oriented programming in general with each cycle of ECMAScript releases. So it's actually kind of nice to use now. But let's dig in really quickly at this concept of encapsulation, in case you don't know what it means, and that's perfectly fine. So we were talking about encapsulation here and encapsulating your code. Encapsulation is the core of object-oriented programming. And what we're doing is we're bundling all of our code into an object that really refers to different states of the object and methods, or what it can do, that represent a particular unit. So we're making our code into a unit. But apart from that, it has another equally important, actually maybe even more so. Privacy, I feel like, is always more important than just like structuring and whatnot. So we want to also think of encapsulation as a protective shield that gives you control. And we love control over our code. It gives us control over how much data you're actually sharing with the public. So as opposed to allowing them in, you're giving them access to your data in different ways. And when you encapsulate code, we can provide those methods as we designate them to be accessible by the public. And like I said, control equals privacy, and vice versa. So they're really important when we're managing our data. So let's do a quick example of object-oriented programming here. Let's say you have a ball. It's a green ball. It's round and it bounces. Okay? If you were modeling this ball as an object, it would have properties, it would have methods, and it would have functions attached to it. So, properties and methods or functions, which methods are functions that are attached to an object. And this property, the property is going to be made up of the name, the property name, and then the property's value. So in this case, we haven't assigned any values yet, but we can kind of assume that based on the fact it's a green ball, the color would be the property name, and that the value of that property would be green. So perhaps we'll give it that property of color, and we'll give it, that value of green. And then with shape and round, it's the same deal. We're defining the actual state of a particular state, I guess. We're defining the state, basically, or returning information on the state based on the attributes that we've given it. And we could even pass in some parameters. Honestly, if you're using a method here like bounce, for example, you can tell it what to do. You can add additional things to it. And so it gives us, again, more control over our code. And the ball's properties can be referenced either via a bracket notation or via a dot notation, which will both basically do the same thing, but the bracket notation allows us to use multi-word. It gives us a little bit more control there too. So how do these two concepts interact or interconnect though? Object-oriented JavaScript and MUDs. I need some water. So, as I mentioned before, all in-game objects, the characters, the rooms that we exist in, can be represented as objects in JavaScript because they are objects. In the text-based role-playing game sense, we can build in-game items with the attributes that we set to them that also inherit parent class attributes. So, in other words, it's really also a way to make our code much drier because we can then create things based on a prototype of other things. That's why I love object-oriented programming. And it's, it made me originally immediately think about MUDs when I started learning object-oriented programming too. At one point, I was actually given an immortal role in one of the games that I was playing, probably just because I was a pain in the ass and they wanted to give me something to do. They're child of the game. And so I was a builder for the MUD, and I was able to create generic items, rooms, whatever, build my own areas that could then be customized. I could generate that entire new room, give it a description, create objects within it, everything. And that was a really cool experience and a great creative outlet until they banned me, I guess. And it was totally their fault because, who gives a 16-year-old power over anything? Seriously. But yeah, I started to draw those connections, and that really was dumb of them. Think of it. But all those objects in game that I created, they had properties and methods attached to them. Yada, yada, yada. We want to make good time here. So yeah, I'm going to combine these two really cool concepts now to show you a bit about those properties, methods, some of the kind of more confusing things that we run into with object-oriented programming. And, but we'll start with a very important concept to understand first, and that's object classes, which is also another central part of object-oriented programming. So one of the core features here is classes. If you're familiar with the concept of inheritance at all too, this will make a lot of sense to you. But in that previous example with the ball, what do we do when we want to create a whole bunch of different balls? Sorry, I'm 15 inside. But what do we do when we want to create a whole bunch of different actual ball objects? We'd have to keep creating new objects, right? And again, we're repeating ourselves a lot of times. Each of these objects is going to have the same properties. What if we just wanted to create a ball class? And then with that ball class, we can use that as a prototype to be able to build a blueprint for creating other objects. And then we can still give those objects unique properties, but at least we know that they're starting with the commonalities. But yeah, we could then shape it and mold it into whatever we wanted. So we have this class called ball, and we have the ability to construct objects based on the ball class or instantiate them. And it's a standard naming convention, by the way. Even in JavaScript, we usually tend to do camel case. But with classes, just to make it very clear that it's a class, we usually use a capital letter for the first letter in there. But yeah, then we can make different types of balls here. We can create things like a football. We can create a baseball. We can create a basketball. And you can see that each of these has its own unique properties and values here based on what type of ball it is. But they have those commonalities still. All right, so the next concept I want to touch on really quick is constructors. Constructors allow us to create new objects and then assign parameters to our freshly instantiated objects. So they provide the instruction, basically, for what to do with and where to put the different attributes that we're looking at. So we put our constructors within the class, which tell the class which values to give any instantiated object that you might be building off of it. So any children, any child objects of that class. And you may have noticed also how I use this in here. And let's talk about this real quick, because this is also a commonly misunderstood concept in object-oriented programming. Wait, that's where I went. Okay. So this is kind of a confusing topic sometimes, but I'll give you a little leg up here if you're new. And I'll explain the problem first, obviously, because that's the best way to learn. So what happens if we want to change a class name? What happens if we want to ensure that all of our future child objects or instantiations, that make sure they have the same attributes and make sure they have the same abilities, anything. If we're really using that as a prototype, we need to make sure that they're making it onto those child objects, right? So, sorry. But in short, we would have to change every instance where we're putting this, we would have to substitute it with the actual class name. So you can see where this is handy then, because it allows you to just reference any child that you create as a result of this. And it is similar to a pronoun. We're using something like they to refer to any of the future objects that we're going to be creating. And it'll adapt. Our code knows what we want. That's an awesome thing, because it's not usually the case sometimes. Let's see. But that's this, in a nutshell, is ensuring that the objects that you're creating are going to inherit those properties of the classes without problems, and that you can change stuff without running into problems down the line. We like variables for those reasons. Now, as I mentioned before, all the objects in a MUD environment can be modeled with JavaScript and object-oriented programming in general. But in the game, I would type something like create sword. And we don't see what's happening under the hood here. But this would be an example for, we haven't actually seen the class yet. But this would be an example of instantiating a new sword or creating an actual object off of a class. But in the game, you're just going to type create sword. So it's a lot more user-friendly, right? So that's what's really appealing. We don't have to deal with the code here, unless you're dealing with the back end and building your own MUD. Where am I here? Okay. Oops, that's weird. Okay. So for example, let's think about the similarities between different types of objects here. What would the similarity be between a generic weapon, for example? That's my generic weapon. And a sword. What are the defining characteristics between those two? Where are they similar and where are they different? What if we're considering a potion that gives you increased health and vitality, and then a food that poisons you? It will poison you too. This thing's awful. A pair of fashionable pants and a pair of battle greaves. So, anybody have a pair of those, by the way, the Jenkos? I did. They were awesome and terrible. I wasn't cool. But yeah, the first and probably the most important question we should be asking ourselves isn't actually how they're different, though. That can come down the line. We should be asking ourselves what they have in common. When two classes have significant commonalities, we'll want to create a class to be able to instantiate with less code. And so between comparing the generic weapon and a sword here, anybody just want to shout out what you think the top level parent of those would be? A generic weapon and a sword? Lower than that, okay. A little above that. It's tough to think about, right? You got to consider what each level has in commonality. I'll tell you, it's wearable. So we're going to have an object, a parent object class here, that allows our player classes, any classes instantiated, to actually hold onto an item and add it to their inventory, no matter what kind of object it is. It's just an object that can be worn. So you can see that these really, sometimes they're very counterintuitive. We're looking at instances where we want to think small, like weapon is going to be in there somewhere as a subclass of wearable. However, there's a lot that might be in between depending on how much you need to reuse that code. Another example that we have, for example, is consumable. and food. Most times when you're looking at a potion versus, your black whopper there, you're considering, okay, those are food classes. Is there anything above that? Well, eventually it's going to be object. But in this case, we're looking at a consumable. It's something that we're going to consume, and then it either destructs that item or maybe it has remaining bytes left. And that's that is the one property that all of these consumable objects, whether they be potions or food or whatever that you can consume, what they have in common. So digging deeper, we know that generic weapons and swords are pretty similar, but they are not the same. The weapon class is going to include some properties that apply to any weapon, but that will also make it more specific so that you're not repeating that code, because some of them have stuff in common. The weapon class will provide properties that make weapons weapons, versus a piece of armor or clothing or food. They can only be held in your left or right hands, for example. You can't wear a weapon on your foot. And you can't hold a weapon anywhere else, but on top of that, they have to be held by somebody, or else they're just laying on the ground, pretty much. I forgot where I was going with that. But yeah, the different swords, for example, and the different weapons that we create will have different amounts of damage, different special abilities, things like that. So we'll either be able to subclass or simply instantiate a sword in order to reflect those unique properties. But yeah, and for example, swords can only be made of certain materials, perhaps. You could be able to make a stone sword, but maybe you can't make a stone axe, and you certainly can't make them from liquid. All right, so let's apply some of this new information about object-oriented JavaScript and see what a weapon class actually might look like when we're modeling it with JavaScript. And I'm not going to go all the way up to the wearable class. That would not work right now. So, and it would involve explaining subclassing. But let's start with building an independent sword class without any of the properties and methods that may have been inherited if we were to go all the way up to wearable. So we're just giving it a blank slate, but we're going to call it sword, and we're going to instantiate off of it. There's our sword. Okay. All right. I think I'm being so fancy when I'm like, let's make things appear once in different times, and then I'm like, what happened to my slide? But first, we're going to create a new class, and we're going to create a class called sword. Again, we have our capital letter there to indicate the class name, and we're going to build the constructor within that class, which accepts parameters in order to build child objects off it. So it kind of does what the name sounds like. We're constructing stuff. And that is telling the class how to construct future instances of it. So let's say, and again, you're going to see this here a lot. And now you can maybe see why it's necessary, because if we were to change the name of any of those things underneath, we're going to have to change it in multiple places. So anything that we can use to save time is helpful. And we're also going to create this, so we are accepting weapon name and weapon type. But at the same time, we're creating this we're setting it to null, this other property named held by. And so we're creating a sword, and we want to know who's holding on to it, right? And so we're going to add this, but we're not setting it to anything yet. Let's go there. Okay. Got some time, I guess, just a little bit. But I'll move faster. So yeah, we got that property there. So we handled those properties, and now we're going to add a method so that the player instance that we create, this is the wrong image for that. Wow. This is what happens when you try and add slides late at night, and you're tired. But, okay, let me see here. Put it. Sword wheel. Okay. Actually, I think I changed it and ended up putting it on the player instead. That's why. Okay. So we'll come to that. Sorry, I'm such a mess sometimes. So we have that parent sword class set up now. And it does not have the wheeled object on it because I changed that. So it doesn't have the wheeled object on it. So what we saw before is exactly what our sword class is going to look like. No further methods. But then when we instantiate that, we're going to name it Sword of JavaScript, because why not? It's a really common typo that I make, and I made it into a whole culture, which is weird. And then we have this object, when we look at it, that has null as a held by value. It's a one-handed sword because we pass that in as our second parameter. And that held by, you'll notice, it was inherited. we created a new sword. We never indicated that we wanted it held by property. We didn't assign it to anybody, and yet it's there. So that's the beauty of classes here. Otherwise, you would have to keep adding that and passing it in. It's going to be null anyway. So there we go. We're going to start with null. You're not holding anything, and the sword is not being held by anybody. Yeah. Okay, and just again, everything in MUDs are objects. And when you play a MUD character, you're actually interacting with these other objects, right? So we're going to take a look at how these actual objects interact. Here, for example, you're going to create a new player. You want to give it a race, and the race maybe is human. You want to give it a name. There's your name. And you want to tell that you can hold multiple items as opposed to a sword, where only one person can be wielding it. So we want to have an empty array here. All right, so now that we built that sword class, we're going to build the player class really quick. And this is the one where I did add the wield method onto there. So we're just going to assume they have hands to hold stuff. They're there. We don't really need to go any further than that in here. And there's a holding array you can tell. Even though we're not passing anything in, we're going to assume this player's not holding anything from the moment that they're instantiated. So yeah, the player class is actually going to have, let me go back to this one. So this player class is actually going to have a wield method, which again, remember, is just a function attached to it. And it's going to tell us, long story short here, if there's an item that exists, then if that item passed in exists, then we're going to add it to, we're going to add that person's name to the held by property of the sword. And then we're also going to push that object onto the holding array that we instantiated that is empty. But yeah, that's what that code would look like, and it would just return, I don't see that here if it doesn't see it. I'm going over, shoot. Okay, let's move forward here. All right, so we have that. And now we're going to make a character. We're going to instantiate that player class. And I know the idea of the whole MUD thing is like really exciting to you guys now. You're sitting there squirming in your seats because you want to log on somewhere. And you know that the sort of JavaScript is out there waiting for you too. So you want to wield that. You're just going to make a character. So you log in and you make a new character. And it's a big old orc. And your orc is named Obama. So we have Obama the orc here. I didn't even bother to remove the background. I was trying to find one with like a stock logo on it too, just to make it even worse. So we already made our player class, and now we're instantiating it like we did. Wait, hold on. Yeah, so we're making our new character, and we're going to assign it to a variable. So we have a variable here, Obama. And we're instantiating a new player here, so you're passing in the parameters of the character's name and the character's race. And because we're putting in that capital P, it knows, and the new, it knows that we're creating a new imprint, basically an instance of this particular class. And if we were to log that out, that actual object, Obama, what you would see is a new object in JavaScript with a name of Obama, a race of orcs, so you can really see those property and value, the name and value pairs there, and then an empty array for holding, so he's not holding anything yet. But we want him to hold that sort of JavaScript that we just made. We want to do it. So let's give Obama that sweet, sweet sword that we made. So yeah, you remember when we made that wield method on the player class? I did not put it on the sword. As it turned out, it was better to do it that way. So on the player class, wait, hold on. I have something else here. So the player class is going to be what allows these two objects to interact. It's checking for something if it exists, it's going through some logic, and then it's making something happen, okay? So if we were to use that wield property, or the method there, and we pass in that sword of JS, which is our variable for the actual sword, we get an output based on the code in that method that says you wield the, and then the name property of whatever you're passing in. You see, we did not tell it to say sort of JavaScript. It just knew because it's getting it from the name value pair of the sword. Yeah, hold on. Oh yeah, I didn't put that in either. Okay, so now we have, Obama has the sort of JavaScript. I wanted to make some really fancy thing there, but yeah, and I wish I could spend more time on this, because you can see how enthusiastic I am about JavaScript and object-oriented programming. I love this stuff. I could create a whole MUD out of it with multiple rooms. But, you can see basically how these objects interact and how they can be created, and the importance of classes, and a little bit about their nuances. So, yeah, thanks so much for coming, guys. And sorry to keep you a little bit late, but add me on Twitter. I'm on here, and I have, yeah, that's it. I'm only on Twitter pretty much. So, and then there's yeah, that's right. I didn't link my Instagram. Thank you so much to Abstractions, too, for allowing me to speak. And I hope you enjoyed my TED Talk.